Watch out for solar sail flares, presented by Science at NASA. Picture the following. It's a calm and peaceful night. Stars twinkle in the velvety darkness overhead as a distant airplane blinks silently on the horizon. You could almost hear a pin drop. That is, until the flare. High overhead, out of the darkness, a bright light surges into view. For 5 to 10 seconds, it outshines the brightest stars in the sky, mimicking a supernova. The silence is broken by the sound of your own excited shouting. Could this happen to you? It could if you happen to be outside when Nanosail D flies by, says Dean Alhorn of the Marshall Space Flight Center. We think the spacecraft could produce this kind of display from time to time when sunlight glints off the reflective fabric of its solar sail. On January 21st, Nanosail D unfurled a 10-meter squared sail in Earth orbit. For the next few months, it will skim the top of the atmosphere, slowly descending in a test of drag sails as a means of deorbiting space junk. If all goes as planned, the spacecraft will disintegrate harmlessly, like a meteor, in April or May of 2011. As Nanosail D gets closer to Earth, it could produce flashes of light some 10 to 100 times brighter than the planet Venus. That's the sort of thing you can see even through city lights. Go outside and take a look. You might see something worth shouting about. For more information about Nanosail D and other NASA projects, please visit science.nasa.gov. The Mysterious Rumble of Thundersnow, presented by Science at NASA. A snowstorm is usually a silent thing. Snowflakes drift down soundlessly from the sky, landing softly on a blanket of white cushioned ground. That's why a freak snowstorm that hit Alabama last month was so surprising. It was downright noisy. As bolts of purple lightning crackled through snowy clouds above, waves of rumbling thunder woke people up and drew them outside in slippers and housecoats to see what was happening. One of those people was NASA Earth scientist Walt Peterson. It was a rare phenomenon called Thundersnow, he says, and it rolled right over our research station at the National Space Science and Technology Center in Huntsville, Alabama. Peterson and colleagues monitored the thunder snowstorm as it raged overhead. They used radars, lightning detectors, and other instruments to probe what was happening inside the tempest. It turns out that deep inside the storm, snowflakes were forming with a mixture of different sizes. Strong, windy updrafts caused them to bump and rub together and exchange electric charge. Think of stalks rubbing on carpet. It's pretty much the same phenomenon. Soon the storm was so charged up that lightning began to crackle, heralding the fall of snow with the loud rumble of thunder. We got a lot of data, says Peterson. When we finish analyzing it all, we'll have a much better idea what causes unusual storms like this. Indeed, snow in Alabama is rare, and noisy snow is just unheard of. Actually, says Peterson, we heard it loud and clear. For more information about Thundersnow and other NASA Earth science research, please visit science.nasa.gov. Super Full Moon, presented by Science at NASA. Mark your calendar. On March 19th, a full moon of rare size and beauty will rise in the east at sunset. It's a super perigee moon, the biggest in almost 20 years. The last full moon so big and close to Earth occurred in March of 1983, says Jeff Chester of the U.S. Naval Observatory in Washington, D.C. I'd say this is worth a look. Full moons vary in size because of the oval shape of the moon's orbit. It is an ellipse, with one side, perigee, about 50,000 kilometers closer to Earth than the other, apogee. Nearby perigee moons are about 14% bigger and 30% brighter than lesser moons that occur on the apogee side of the moon's orbit. The full moon of March 19th occurs less than 1 hour away from perigee, a near-perfect coincidence that happens only once every 18 years or so, says Chester. A perigee full moon brings with it extra high perigean tides, but this is nothing to worry about. In most places, lunar gravity at perigee pulls tidewaters only a few centimeters, that is an inch or so, higher than usual. Local geography can amplify the effect to about 15 centimeters or 6 inches. Not exactly a great flood. Indeed, contrary to some reports circulating the internet, perigee moons do not trigger natural disasters. The supermoon of March 1983, for instance, passed without incident, and an almost supermoon in December 2008 also proved harmless. Okay, the moon is 14% bigger than usual, but can you really tell the difference? It's tricky. There are no rulers floating in the sky to measure lunar diameters. Hanging high overhead with no reference points to provide a sense of scale, one full moon, even a supermoon, can seem much like any other. The best time to look is when the moon is near the horizon. That is when illusion mixes with reality to produce a truly stunning view. For reasons not fully understood by astronomers or psychologists, low-hanging moons look unnaturally large when they beam through trees, buildings, and other foreground objects. On March 19th, why not let the moon illusion amplify a supermoon that's extra big to begin with? The swollen orb rising in the east at sunset may seem so nearby you can almost reach out and touch it. Don't bother. Even a supermoon is still 356,000 kilometers away. That is, it turns out, a distance of rare beauty. For more information about moons, super and otherwise, visit science.nasa.gov. Scientists crack the mystery of the missing sunspots, presented by Science at NASA. Back in 2008, something funny happened to the Sun. All of its spots disappeared. For nearly 2 years, in 2008 and 2009, sunspots were extremely rare. The face of our star was utterly blank for weeks and months on end. Astronomers call such an event solar minimum, and this was a big one. Solar activity dropped to 100-year lows. Earth's upper atmosphere cooled and collapsed. The Sun's magnetic field weakened, allowing cosmic rays to penetrate the solar system in record numbers. Solar physicists openly wondered, where have all the sunspots gone? Now they know. The answer was published in the March 3rd edition of Nature. Lead author Dibyendu Nandi of the Indian Institute of Science Education and Research explains what happened. Rivers of fire on the Sun disrupted the formation of sunspots. Just as the oceans of Earth have vast and powerful currents that straddle the globe, so does the Sun. Except the Sun's great currents are made of hot plasma instead of cold water. Sometimes we call them rivers of fire, and these rivers play an important role in the life cycle of sunspots. The rivers of fire drag old decaying sunspots down into the Sun's interior, where they are reanimated by the Sun's magnetic dynamo, explains Nandi. These reborn sunspots pop up to the surface for the next solar cycle. According to the group's computer models, the Sun's current system sped up and started dragging old sunspots through the dynamo so fast they didn't have time to be fully reanimated. And that's what caused the deep solar minimum of 0809. Now things are getting back to normal, and solar activity is picking up. Big sunspots and solar flares have returned. But when will they disappear again? The answer lies in a river of fire. For more information about sunspots and other NASA heliophysics research, please visit science.nasa.gov.
The superfluid core of a dead star, presented by Science at NASA. Neutron stars are very strange. For one thing, they're made of neutrons, but that's just for starters. A neutron star, the entire star, is smaller than the town you live in. Some of them spin around on their axis so fast they can complete one revolution in less than a millisecond. And a mere teaspoon of a neutron star's solid crust weighs more than 1 billion tons. Very strange indeed. But would you believe they just got stranger? Astronomers using NASA's Chandra X-ray Observatory have discovered that neutron stars, one of them at least, has a superfluid core. A superfluid is a bizarre, friction-free state of matter that, here on Earth, exists in laboratories at temperatures near absolute zero. Superfluids have no viscosity, but they do have surface tension. This weird combination causes superfluids to try to climb out of any cup they are placed in, slithering up the sides and over the rim. Superfluids also have infinite thermal conductivity. They spread heat very rapidly. The thermal character of superfluids is what led to their discovery in a neutron star about 11,000 light-years from Earth. The neutron star is spinning inside a supernova remnant astronomers call Cassiopeia A, or Cas-A for short. Neutron stars are born in supernovas. They are the dead remnant cores of exploded stars. The Cas-A explosion happened about 330 years ago, as seen from our planet. That means the neutron star is relatively young and still cooling off from that ferocious blast. It's cooling off so fast, in fact, it must have a superfluid inside to help conduct the heat. That was the conclusion of astronomers, who measured the temperature of the star using Chandra and found that it had cooled by about 4% over a 10-year period. This drop in temperature, although it sounds small, was really dramatic and surprising to see, says Danny Page of the National Autonomous University in Mexico, who is leading one of two teams studying the phenomenon. This means that something unusual is happening within this neutron star. Now, when an astronomer says something unusual is happening inside a neutron star, you know it's got to be pretty weird. Page's team and others will continue monitoring the Cas-A neutron star, measuring its temperature and spin rate to see if they can learn more about how superfluids behave at high temperature and density. It's the kind of information they could never get from an Earthbound lab. Stay tuned to Science at NASA for updates from Cas-A and other dead stars around the Milky Way.